Hello everyone. Today I am going to explain you series LCR circuit. This topic is very important, most important problem. In every type of exam, definitely you will get some questions from this topic, series LCR circuit. Let us consider a LCR circuit, or we can say a circuit containing pure resistance. Say value of resistor and its resistance R, and inductance, a inductor of inductance L, and a capacitor of capacitance C. They are connected in series. किससे? With an AC source of EMF E is equal to E0 sin omega t. This I shown in here. I already know figure 1 series LCR circuit. I will explain you this remaining portion. That's why I draw a diagram again. AC circuit containing a resistor R, inductor of inductance L, capacitor of capacitance C. They are connected in series with an AC source of EMF E is equal to E0 sin omega t. Now, we already discussed in the previous topics. In the case of pure resistive circuits, the current and EMF both rise in the same phase. You already have discussed here. Therefore, I draw it here, say I and VR. And inductor, in the case of pure inductive circuit, the current is lags behind by phase pi by 2 with VR. Matlab, I is lags behind by VN in the case of pure inductive circuit. And in the case of pure capacitive circuit, the current is ahead of my phase pi by 2 with VC, voltage across C. That's all three conditions show here. The I and VR both are in same phase in the case of pure resistive circuit. VL and I has some phase, it is pi by 2. In the case of pure inductive circuit, current is lags behind by phase pi by 2. And in the case of pure capacitive circuit, current is ahead by phase pi by 2 with voltage in the case of. Now, we will discuss it in detail. So, the voltage. Now we calculate the voltages across pure inductor, pure resistor, pure capacitor. So, and all these three are connected in series. Then we calculate the effective voltage, effective current, and effective resistance, that is called impedance of the circuit. So, the voltage across the resistor are these 2 points. If that is according to Ohm's law, V is equal to IR. Current flowing through this is say I, then it's become VR is equal to IR, and VL is equal to IXL, and VC is equal to IXL. We noted down all these here. So the EMF of AC source we given E is equal to E0 sin omega t. Sorry, and voltage across the resistance are VR is equal to IR. This is your equation number 1. This is your equation number 2. And VL, voltage across the inductor of inductance L is VL is IXL. What is XL here? XL is resistance offered by the inductance in the AC circuit. That is called inductive reactance, that denoted by XL. And similarly, the voltage across the capacitor C is given by VC is equal to IXC. This is your equation number 4. And this XC is called capacitive reactance of the capacitor. Okay, so these are the three. Now, I will explain you the phasor diagram for this series LCR circuit. So, try to understand this phasor diagram. We know that in the case of pure resistive circuit, I and E are, or I or voltage in the same phase. So, if it is your x-axis, so if we say current along x-axis, so in the case of pure inductive circuit, this is voltage also along this direction. This is VR. And its value is IR. In the case of inductor, the current lags behind by phase power 2 with voltage. So, your value of, say it is VL, so it says phase power 2 with I. You can say it is I. And in the case of pure capacitive circuit, current is ahead by phase power 2 with VC. So, if it is VC, so this is your power 2 current. I draw this diagram already here. This is for I. So, VR, OA represent the VR, OB represent the VL, and OC represent the VC. Here I assume the case VL greater than VC. You can take also VC greater than VL. We will discuss in the next topic. So, VL greater than VC. So, if VL greater than VC, so it is plus pi by 2, it is minus pi by 2. So, it is along upward direction. This is along downward direction. So, net effective voltage is comes out VL minus VC, say this one. So, that I mark here at point D. So, VL minus VC. If then you complete your parallelogram, then diagonal of the parallelogram give you resultant voltage or effective voltage of the circuit. It is denoted by V is also given as a E, and it is equal to IZ, and its value we will calculate now. Okay, it's clear? So VL, VC and VR you can show in a diagram. That diagram is known as phasor diagram. So this diagram is called a phasor diagram for LCR circuit. Here I assume VL greater than VC. Remember this thing. Here we assume it VL greater than VC. So, by the Pythagoras theorem, apply in this triangle OAP. What is Pythagoras theorem? Hypotenuse square is equal to base square plus perpendicular square. So, V square is comes out VR square plus VL minus VC whole square. OA square plus AP square is equal to OP square. Then I wrote down this V also, we can say it is E. So E is equal to square root of VR square plus VL minus VC2 whole square. This is your effective voltage of LCR circuit. And if VL greater than VC, so this current is lags behind with this. We will discuss in detail after some time. Now, I will explain you impedance triangle. What is impedance triangle? So, we know that voltage is equal to IR, VL, IXL, VC is equal to IXC. So, in place of this VL minus VC, we can write down IXL minus IXC whole square, I outside. So, this become XL minus XC. So, we can draw this diagram. So, this is your XL minus XC and this is your R. So, this is a case when XL greater than XC. Remember these things. So, Z is comes out again by Pythagoras theorem, base square plus perpendicular square. So, it become R square plus XL minus XC whole square, value of z square. So it is say r square root. So z is comes out square root of r square plus xl minus xc2 whole square. This triangle is known as impedance triangle. Say this figure 3 represent the impedance triangle. Say r xl minus xc, and this phi is your phase between E and I in the case of LCR circuit. So I will again come to this phasor diagram and find out this value of E for you. So in triangle OAP, this OA square plus AP square is equal to OP square. Or you can say OP square is equal to OA square plus AP square. So E is comes out under root of what is OA? OA means IR. I square R square plus AP means this VL minus VC. So VL minus VC की value IXL and IXC. So I square XL minus XC whole square. Taking I square common, so E is comes out and then square root, so it's become I under root R square plus XL minus XC whole square. So E is E upon I, that is called resistance, or in this case impedance of the LCR circuit. It is equal to square root of R square plus XL minus XC whole square. Clear up to this step? So this is your value of impedance. E is given by this relation V square plus VL minus VC whole square, or I under root R square plus XL minus XC whole square. Or impedance of LCR circuit is given by this. And this is your impedance triangle. Z is equal to under root R square plus XL minus XC whole square we will get from this impedance triangle. Okay. Now we will discuss some special cases. Case 1. When and with the help of that special case we find out the expression of I, phase relationship between E and I in the case of XII circuit. So case 1. Case 1 I will take when XL greater than XC. Case 1. क्या ले रहे हैं हम? XL greater than XC or VL greater than VC. So when XL greater than XC or VL greater than VC, then current is lags behind by phase phi, and its value of phi you can calculate from this triangle tan phi, or from impedance triangle also. Tan theta equal to perpendicular upon base. Perpendicular is here XL minus XC upon base is R. So by this relation you can calculate the value of phase, and the current is lags behind. So expression for current I is I0 sin omega t minus phi, and phi you calculate from here. This is your case 1. Now case 2. In the case 2, when XL equal to XC, क्या assume कर लिया हमने? XL equal to XC. तो if XL equal to XC, तो क्या होगा? If you put it here, phase become 0. So tan phi is comes out 0. Okay? इसकी value 0. So phi is equal to 0. And in this case, I and R in the same phase, so I is equal to I0 sine of omega t. This is your case 2. Now case 3. Reverse of this. XC is greater than XL. That's why I told you that I will explain after some time. तो नाउ केस 3 क्या ले रहे हैं हम, XC greater than XL. What happened in this case? When XC greater than XL, so if you draw the diagram again, I draw for your simplicity impedance triangle. In this case, this is your x-axis. Say current is here, and this is say XL, and now XC is greater than. So finally your XC minus XL now in the downward side. Then you complete the triangle, parallelogram, and get the triangle in this here. So in this case you get the phi is here. So this is your XL minus XC with negative sign. So you can say XC minus XL. So here tan phi is comes out now XC minus XL upon R. Perpendicular upon base. This is your R. And this is your phi. This is your current. Here this is voltage. So in this case, I is ahead of phase by phi. Current आपकी क्या हो जाएगी? Ahead हो जाएगी with phase phi with EMF. So I is comes out I0 sin omega t plus phi. So we can summarize all. You can say in the pure इंडक्टिव सर्किट कब होगा, प्योर इंडक्टिव, प्योर कैपेसिटिव, प्योर रेजिस्टिव, ये हमने डिस्कस कर लिए थे लास्ट लेक्चर में. यू आप अपने वो वीडियो भी देखिएगा. तो 3 केस हमारी कंडीशन आई है कि व्हेन XL ग्रेटर देन XC, तो फाई आपका क्या हो जाएगा, tan फाई निकाल लीजिए, या tan इनवर्स ऑफ XL greater than XC. So this one XL minus XC upon R. Then one. Second, XL equal to XC. We will discuss in the next topic. This is called resonance condition. In this case, phi is 0. And third one is your XC greater than XL. Then you will get phi is equal to tan inverse XC minus XL upon R, and here I is I0 sin omega t. क्या हो जाएगा, जब ये नीचे रहेगा तो करंट आपके क्या हो जाएगी, अहेड हो जाएगी प्लस फाई, करंट वहां आ जाएगी. तो ये आपके बहुत बहुत इंपॉर्टेंट है. आपको कोई भी डाउट हो मेरे को व्हाट्सएप कर दीजिए. मेरा व्हाट्सएप नंबर है 941071118554, और इसका स्क्रीनशॉट भी ले लीजिए. डायग्राम आपके बहुत हेल्प करेगा. थैंक यू वेरी मच. प्लीज शेयर एंड सब्सक्राइब माय चैनल.